Hello, my name is Ben Taylor and I'm Global Projects Manager at Metrol Technology, and I'm here to tell you a little bit about the value of wireless completion monitoring today. So Metrol are a UK-based company. We are specialists in downhole wireless sensing and wireless valve control. We've been around for over 30 years, most of which have been involved in actively running downhole wireless systems. And whilst we work globally, Marwell are Metrol's representatives for completions in Norway. Metrol are looking forward to exhibiting at the Productivity Forum next month in Stavanger, where Marwell are sponsors, and we will have a joint stand. So just imagine, what if you could wirelessly monitor right down at the sand face and control production based on not what you've modeled beforehand, but on what you're actually measuring downhole. As I mentioned, Metrol have been monitoring directly at the sand face for almost 30 years in various forms. And today, and for the last 10 years or more, in fact, we have been monitoring wirelessly with completely wireless transmission from the bottom of the well to surface. And this allows us to monitor an instrument without wires, penetrators or feed-throughs several kilometers in, for example, horizontal open hole sections. It allows us to see, using high resolution sensing methods and using wireless valves, again without penetrators or feed-throughs, it allows us to identify water coning and to choke that back. We can see where gas coning occurs and control that. We can increase production by understanding which areas of the productive intervals are producing and which aren't. And we can actually, through our measurements, we can allocate flow to inflow to certain intervals directly at the sand face. So each zone, we understand exactly how much we are producing and from where inside the well. And not only do that, but actually physically react to it. And it's the value in having this wireless data is in our ability to respond to those data. So using this real life example, where we have our 3D visualization software, and you can see we have two zones of interest, two net pay zones, these gray bands, an upper zone and a lower zone. And we can see that when the well is flowing, that we are producing from the lower interval and that oil is cooling as it travels up the well bore. And we can see that both zones are flowing. So we get a lot of information and feedback as we watch individual sensors, temperature sensors, deviate from the geothermal gradient in near real time directly at the sand face. And we actually learn even more about the reservoir and the reservoir parameters when we shut in the well. And in this real example, we can see that as soon as we shut in, that we get cross flow of where oil is producing from the upper zone and then cross flow and traveling into the lower zone. We get more reservoir understanding during the shut-ins. So how do we monitor these specific intervals? Well, we use a combination of wireless and we use a combination of sensors. So we use electromagnetics, which we tend to operate in the open hole or in wells where there's no production tubing. or we use acoustics to transmit up and down production tubing. And we use either of these types of telemetry, and what Metrol do uniquely is combine both types of telemetry inside wells, where we can use EM in the open hole sections and acoustic inside cased hole, for example, in order to optimize the volume of data that we transmit to surface, optimize the speed that we send data to surface, and optimize the lifespan that systems last. But very importantly, this wireless telemetry allows us to access the memory of our wireless sensors. So all our tools are recording at maximum resolution, maximum sample rate, all of which is fully controllable from surface, but they're recording directly at the sand face, and we're using our wireless telemetry to upload just the data that we need from those tool memories. So we can install wireless gauges with very high pressure resolution, 0.008 psi resolution. We can install them directly at the toe, middle and heel of open hole sections, for example. We can install them in abandoned wells to look at interference pulses that may be generated in wells as far as 10, 12 kilometers away. And because our temperature resolution is so high, we can actually combine the data from the temperature and pressure sensors to also allow us to get an understanding of flow or injection into certain intervals. We've now designed the carriers and the tools in which we run these sensors to be pushed out into extended reach horizontal wells to be able to withstand the high compression, high collapse rating that's required to push these tools through cuttings that can't be circulated out on the low side of horizontal wells. And this is proving very effective, and we'll talk about a case study or some case studies very shortly. But we also run wireless temperature arrays, and Metrol have been running for many years a system called Prolog. We've run it in Norway many times. We can install this Prolog, this wireless temperature array, as part of the lower completion. And we run a number of high resolution temperature sensors inside heavy walled 3/8 of an inch diameter, heavy walled liner directly at the sand face. We can run it on screens, we can run it on liner, we can run it on the outside of TCP guns. In fact, the majority of the work we do is actually monitoring on the outside of guns as and when they fire. So it's a hugely robust system with a great run history. We can combine it with our pressure temperature gauges. And the value or the real benefit of our Prolog system is that it acts like a permanent PLT in the well. So we have a near real-time inflow profile where these sensors are run directly across the sand face. It's like a permanent PLT inside the well. One of the main enablers for running wireless in the completion environment is battery capability. And there's a perception, thanks to our iPhones and other battery-powered devices, that batteries do not last a long time. But actually, Metrol have actively been running systems in completions for well over a decade. We are actively monitoring systems that have been monitoring for 13 years now, wirelessly, powered off old power management systems, off old battery technology. And we have completion systems dotted around the world that we're still monitoring today, 10 years after deployment. But we now have new battery technology, we call them our endurance cells, that we're actively running in completions today, that give us an absolutely game-changing lifespan at lower temperatures. So at lower temperature, I mean 70 degrees C. At 70 degrees C, we could, just by with conservative data transmission, by which I mean a point per day, for example, we could last 30 years. And at lower temperatures in shallow injectors, for example, we could last as long as 45 years. And as the temperature increases, the lifespan becomes less, but still at 100 degrees C, we could be transmitting as much as 15 years, 120, 8 years, and so on. It's truly game-changing, and we don't just say that we can do it. We have been out there doing it for a long time. But we genuinely believe that this is a life of well solution in low temperature environments, not just completions where we want to obviously increase production, but also in gas storage, carbon capture environments as well. So the systems can either be completely wireless and transmit wirelessly using a number of acoustic or EM repeaters directly to surface. We do this both in completions, well abandonments. We do it to control the prolog systems that we've just talked about, our temperature arrays to understand inflow. We do it to understand pressure in individual reservoir compartments. And of course, we use it to control our wireless valves so that we can use, for example, use and isolate aquifers to dump flood low pressure zones online. We can use it to control flow from individual reservoir compartments. And we can do it to completely bypass all existing subsea comms infrastructure as a sort of a late installation option, should you not be able to run a cable system that you would like. But in the last 5 years, we've also qualified an interface system with Roxar, with Emerson, with Roxar's trusted permanent downhole gauge. And their cabled gauge becomes our wireless entry point into the well. And we've recently been installing these for operators in Norway. And we just very simply add a wireless unit using our standard wireless telemetry devices to Roxar's standard HS gauge, and we provide a wireless interface between the two. Hugely successful, very, very simple. It quite literally means you have one lift that you had anyway for a gauge carrier, and that means that we can save the money that would be spent on wireless telemetry back to surface. We can send data directly back to the host platform. And it means that in some cases, all we need to do is literally replace a joint of 4.5-inch liner with our smart wireless gauge, and we can transmit several kilometers without any other infrastructure or the need for penetrators or feed-throughs in the completion packers or liner hangers. We just transmit wirelessly into the horizontal open hole sections. So we have been doing this. We are doing this for clients around the world. We have an established run history. We will be installing a system very similar to this in the Gulf of Mexico later on this year. You can see photographs of the SIT and our prolog thermal imaging on the right-hand side. And we're actually pushing these lines out into 6.5-inch open hole. We've got an outflow injection temperature profile in the open hole. So for the first time in this field's history, the client will suddenly understand where they're injecting into in their low temperature injectors. And of course, they will be able to adjust injection accordingly, and we will be able to monitor in the corresponding producers. We'll be able to understand compartmentalization in the reservoir. And we're doing this because they've never been able to run a PLT in these wells. They can't get the tools down there. It's an online operation, and it's very risky to wells that are costing hundreds of millions of dollars to install. But very importantly, it will give us feedback on the stimulation plans that they have for the future. So again, very simple, very cost-effective solutions. And these big operators in the US have qualified these systems to their own standards, not just one operator, multiple operators. And lastly, we've had 4 very successful well installations for a Norwegian operator over the last few months, where we have been installing these open hole EM gauge carriers to literally just replace a joint of 4.5-inch tubing with this smart pipe, and to allow us to instrument both the toe and the heel of the open hole section. And we are wirelessly transmitting nearly 2 kilometers in some cases from these wireless gauges at the toe back to the Roxar permanent downhole gauge and our matrix wireless interface back up through the cable and the subsea vendor to the host platform. And having data, because these tools are battery powered, they're recording from the time that the batteries went in at surface. So we're getting feedback during running in hole, and we're helping the client to understand cleanup efficiency. And they told us that they might be able to, or could in some cases, shorten the cleanup by 50%. It's providing operational diagnostics. Is the toe sleeve open, or is it closed after we've landed out? We're using these systems to provide interference data between the wells in the suspended period prior to them being brought online. But the real value driver, the real business driver for installing systems in the first place was to avoid what that client currently spends thousands of hours modeling where they will be producing from, what will be producing from where. And rather than modeling, or by reducing the modeling hours, we can reduce the modeling hours by monitoring where it counts directly at the sand face, removing those tubing friction effects, removing wellbore storage effects, and providing very high resolution within the reservoir compartments of interest. And that is also allowing them to understand compartmental contribution, and then in the future, improve their drainage strategy. So the value of these systems, the value of wireless data and wireless control really lies in our ability, or our client's ability, to respond to the data that we provide them. And it leads to generally to increased production, adapted development and design, and downhole well control using the instruments that we have provided. Thank you very much for the opportunity to present. Over to you, Mike.
Okay, thank you very much, Ben. Very interesting presentation. My name is Mike Byrne from Axis, based in Aberdeen. Well, based at home at the moment, but out of an Aberdeen office. And I am a member of the organising committee and the technical committee for the European Well Productivity Forum in Stavanger on the 6th and 7th of October. We're going to be joined as well by Peter from Marwell, and I think both Ben and Peter will take questions, and Peter may have some questions or may want to add to what Ben has already said. So I'd like to kick off, if I can, with a question. And you mentioned this recent installation or installations in a Norwegian field. Is that a global first, or have you installed similar length horizontal wells before?
It's not a global first for running this type of technology or these sensors, but I think it's a global first in terms of the way that that particular client is using wireless systems, absolutely. But we have deployed the interface with ROXAR and the electromagnetic gauge technology elsewhere in the world also.
And so maybe as a follow-on, so do you have good pressure and by implication rate data from the toe sections of long horizontal wells?
Yeah, we are providing wireless monitoring in all sorts of flowback environments, but also a lot in abandoned well scenarios, or abandoned sidetracks. So for example, where pilot holes are drilled to gather information prior to sidetracking and drilling a main production bore, very often we install EM gauges in multiple zones to monitor interference between main production bore and those abandoned gauges, and whether it be for vertical or horizontal interference testing. And in some cases, it's providing understanding about pressure relationships between reservoirs and aquifers, and it's allowing some of our clients, once understanding that aquifers will not interfere with production, it's allowing them to perforate secondary intervals and produce more.
Okay, and maybe Peter, do you have any comment or question?
Thanks, Mike. So Ben, you mentioned that you can communicate wirelessly several kilometers, between the sensor, between your devices. Can you elaborate a little bit on, what affects that wireless communication and what may limit it or make you able to communicate further?
Yeah, good question. Thank you, Peter. So to answer your question, everything affects wireless transmission, but obviously, having done it for nearly 30 years, we have a lot of empirical data about how to manipulate these wireless signals, how to deal with high noise in the well, how to position our tools, optimize those tools where signals will become attenuated. So there is no limit on, in terms of well length or well depth, other than considering pressure and temperature. There's no limit on how far we can transmit, and we've transmitted in wells nearly 30,000 feet deep. We just add an additional repeater. But in some cases, the formation resistivity and the completion parameters can be so favorable that we can transmit 8, 10, 12,000 feet without the need for wireless repeaters. And that applies to both acoustics and our electromagnetic technology.
Thank you. I'm also curious, could you elaborate on how these signals or the data is received at the host? That be the rig or any software that the client would use. Could they bring this into their own software?
Yeah, so Metrol have worked with most major operators over the last few decades, and we provide data in a format that can be inputted or harvested or grabbed by their surface SCADA systems. So there are considerations when doing that, but generally what we're doing today is providing data in a place on the host platform where most of our clients are using Pi, so where their Pi historian can grab that data and input it into the system. But if we're brought to the table to provide a completely wireless solution, and many clients do, for us to provide wireless backups, to cabled solutions, or in wells, for example, workovers where there might not be electrical penetrators to run conventional cable systems, it's important to note that we have wireless ways of not just transmitting downhole, but actually transmitting through the subsea architecture and then transmitting wirelessly either in a dry tree scenario via satellite comms or in a subsea environment using sonar through the water to be able to get data back to surface and bypass the infrastructure that would normally take perhaps 2-3 years of planning in order to interact with it. So we can bypass all of it and actually deploy systems very, very quickly with a minimum of interfacing.
Yeah, Ben, I've got maybe a very simple question and maybe betrays my ignorance of the topic, but how do you discriminate between different fluid phases with this kind of sensing?
So, well, we run a number of tools, and with our high resolution temperature arrays, the temperature resolution is so high that it can actually pick up subtle temperature changes that are related to frictional effects by producing different fluids as they enter into the wellbore. But we can also see that through fluid gradients. We can see it by careful positioning of these high temperature and pressure resolution gauges at strategic points within the well. And we also have a wireless fluid ID tool that can be run as well.
And I guess where my question comes from is that one of the values that you emphasized was the ability to determine where water and or gas are coming into a well, and therefore being able to control that. And so I guess identifying exactly where these fluids are coming in is key, and that presumably will depend on how many devices or how many sensors you have in the well. Can you have many sensors in a well?
Yeah, really good question. So yeah, we're obviously in completion design, we're often restricted by the number of penetrators that we might have between upper and lower completion. And in some subsea environments, well, in most subsea environments, running fiber optics, for example, into lower completions is near impossible because we don't require penetrator or feed through, and we can do this wirelessly. It allows us to run temperature arrays across, in some cases, across the entire horizontal interval, so we can see exactly where inflow occurs. But where we're using standalone tools, we actually have over 1,000 usable channels that we can control tools with. So that could be 1,000 sensors, 1,000 wireless transceivers, 1,000 valve actuators. Typically in a completion, we might use 40 of those channels. So really, there's no practical limit on the number of tools that we can run.
And again, I think I heard you mention that you can have sensors inside and outside the completion, for example, in sand screens or ICD completion. So presumably you can detect reservoir to annulus and annulus to tubing in the same well.
Absolutely, and we often do so in the same gauge mandrel, so at the same points inside the well. But we have over the last 30 years been installing these systems on any kind of tubular. So that's ranged from 1-inch OJ tubing and sucker rod in beam pump wells through sort of 2 3/8 completion, 3.5, 5.5, right up to large casing diameters, quite literally up to 36-inch conductor casing we've attached to and communicated through all of them. So we actually do quite a bit in terms of truly wireless annulus B and C annulus monitoring inside the well and at reservoir depth as well. So we're not just restricted to sort of monitoring conventionally within the production tubing and in the A annulus as such. We can monitor in any of those spaces using this wireless communication.
Thank you. Peter, do you have anything further to add or ask?
No, I'm good, Mike. I think I got my questions answered.
Okay, well, thank you very much to both of you, and I look forward to meeting you in person in Stavanger in a few weeks.
Thank you very much for your time.